Welcome to another Smash Jam series, and today we're going to be looking at the topic atomic structure and bonding. Now, the first question says, which of the following bond types involve the transfer of electrons? Now, when it comes to bonding, all right, when you hear electron transfer or transfer of electron, you are talking about electrovalent bonding or ionic bonding. All right, so electrovalent bonding or ionic bonding has to do with transfer of electron or electron transfer. So the correct option is what? Option what? B is our correct answer. Now, the next question says the dominant intermolecular forces in ethanol are the dominant intermolecular forces in ethanol are A, you have London dispersion forces, B, you have dipole forces, C, you have hydrogen bonding, and D, you have ion dipole forces. Now, listen. Ethanol, all right, ethanol is an organic compound that has an OH group, which has the ability, is also a polar, all right, is a polar compound or a polar substance, all right. It has the OH group, which has the ability to what? Form hydrogen bonding, all right, with other ethanol molecules, all right. So the dominant intermolecular forces in ethanol, because of this OH group, is hydrogen bonding, all right, hydrogen bonding. Now let's go to the next question. Now the next question says that what? The characteristic crystalline shape of solid water is due to what? A, covalent bonding, B, hydrogen bond, C, ionic bonds, and D, metallic bonds. Now, water molecule form bonding with other water molecule, resulting into a six-sided shape what? Crystalline, all right? Six-sided shape crystalline. So what I'm trying to say is that hydrogen bond, the characteristic crystalline shape of solid water is due to hydrogen bonds, all right, due to the what? Hydrogen bonds. Now the next question says the bond formed between H2O and H plus to form hydrozonium ion H3O plus is, now we have dative bond, we have B, covalent bond, we have electrovalent bond, and we have ionic bond. Now it said the bond formed between H2O and H plus, all right. Now the bond formed between this and this is what? Dative or coordinate bonding, all right. Coordinates bonding, either dative or coordinate bonding, where they share electrons, all right. So because they share electrons, they are what? The bond between them formed between H2O and H plus is what? Dative bonds. Now let's go to the next question. All right, the next question says what? The bond that exists in ozonium ions are what? A, covalent and dative, B, covalent and ionic, C, dative and ionic, D, metallic and dative. Now we are talking about ozonium ions. Now the bond between hydrogen and what? Oxygen is formed by a covalent bond, all right. Then and hydrogen and oxygen is going to give you water, all right, and that is what? That is, they are formed by covalent bond. Then water and hydrogen ions are bonded by what? By dative bonds, all right, by dative bonds, all right. So hydrogen and oxygen are bonded together by what? By covalent bonds, all right, and they will form water. Then now water and the hydrogen ion are held together by dative bonds, all right. So the correct option is option A, all right, covalent and dative bonds. Now the next question says the bonds in naphthalene molecules are, now naphthalene molecules are strong solid molecules, and the forces that is between the bonds in the naphthalene molecules are simply van der Waals forces, all right, simply what? Van der Waals forces. Now let's move to the next question. Is in ammonia molecule the number of non-bonding electrons is or are? Now of course we know that ammonia is NH3, all right. Now let's draw the molecule structure or the molecular structure of ammonia. So we have N, all right, then we have this, we have this, and then we have this. We have H, 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 and then we have this, and then we have this. We have this, and then we have this. We have this, and then we have finally this. All right. So now it says in ammonia molecule, the number of non-bonding electrons is or are. Now you can see clearly from the structure of the molecule of ammonia that we have two non-bonding electrons. All right. Only this is a bonding electron. So these two are non-bonding electrons. So our correct answer is option B. That is two non-bonding electrons is the correct answer. Now let's move to the next. Now the next question says, which of the following has zero-fold degeneracy? All right. Now we have option A, P. We have option B, S. Option C, D, and option D, F. Which is the SPDF? That means the spin principal diffuse fundamental. All right. Now let's see. Let's analyze this. Now the S has zero-fold degeneracy. All right. The P has what? Three-fold what? Degeneracy. Then the D has what? Five-fold degeneracy. And then the F has seven-fold degeneracy. All right. So it means that our correct answer is what? S, which is option what? B, because S has what? Zero-fold degeneracy. Now the next question says the maximum number of electrons that the N shell can accommodate is. Now we have, of course, we have the K, the L, the M, and then the N shell. All right. Now the formula we use to find the maximum number of electrons that any shell can contain is what? 2n squared. All right. So when n is equal, we have for K, you have when n is equal to 1. For L, you have n is equal to 2. And for M, you have n is equal to 3. And then for N, you have n is equal to 4. And they're asking us the maximum number of electrons that the N shell can accommodate. Now the N shell, when we're looking at the N shell, we have when n is equal to 4. All right. KLMN. All right. So it becomes what? 2 into the bracket what? 4 to the power of 2. So this becomes 4 squared is what? 4 times 4. That's 16. And 16 times 2 gives us what? 32. So the maximum number of electrons that the N shell can accommodate is what? 32. All right. So option C is correct. Now the next question says the electronic configuration of Na+, that's sodium ion, is A, 1s2, 2s2, 2p6, 3s1, B, 1s2, 2s2, 2p6, C, 1s2, 2s2, 2p6, 3s2, and then D, none of the above. Now, how do we solve this question? How do we analyze this? Now, I want you to know that there's a difference between sodium and sodium ion. Now, this is a neutral sodium, but this is a charged sodium. All right. Now, when you see Na+, all right, this is what? Sodium what? Ion. This means that it is now in a state where it is carrying a charge. All right. And actually, it is actually called a cation. All right, because a positively charged ion is called what? Cation. So it's actually a cation. All right. Now, when you see Na+, it means that it has lost one electron. You know, there's a song we used to sing. Blessed is the hand that giveth, than the one that taketh. So it is the one, you might have thought that because of you are saying he gave out one electron, it's supposed to be minus. No, it's not supposed to be minus. It's going to be plus. It is because it has excess. That is why it was able to give out. All right. It is the one that has that can give out. All right. If you don't have, you can't be able to give out. So when you see Na+, it means that it lost one electron. All right. Now, when you come to sodium, your neutral sodium, you have 2311. Now, 23 is the mass number. 11 is the what? Number of protons, or the what? Electronic, the atomic number, sorry, or the number of protons. All right. Now, when sodium is neutral, all right, the number of protons is the same with the number of electrons. But when sodium is in its charged state, the number of protons, it will now be different from the number of electrons. Now I told you that it has lost one electron, meaning that it now has it now has what? 10 electrons. Now it now has 10 electrons. So if we are filling the orbitals of this electronic configuration, it's going to be what? It's going to be 1s2, 2s2, 2p6. All right, so option B is correct because 2 plus 2 plus 6 gives us what? 10. All right, if it was just ordinary sodium, all right, which is neutral, the electronic configuration would have been what? Option A. But because it has lost one electron, it now has 10 electrons. Filling the orbitals, you're going to have what? 1s2, 2s2, 2p6, which is option what? B. Now, that will be all for this topic, atomic structure and bonding. Make sure you like this video, share this video, and hit the subscribe button. So when I post more videos like this, you get notified.